So hello guys, welcome back to another lecture on Basics of Mechanics lecture series. My name is Bharani Deepak and I am introducing you to the concepts of understanding forces acting on the body. In the previous two lectures, we learned about the Newton's laws of motion and how to resolve an inclined force into their horizontal and vertical components. Today, we will learn how to characterize a force, what are the system of forces, and finally, we will see about the resultant force. Okay, now let's get started with characteristics of forces. What is characteristics of force? Well, these are the things that help us to define or rather properly represent a force. If I give you a stationary block and ask you to draw three forces acting on it, you would go ahead and draw the self-weight of the block in downward direction and a reaction force from the surface at which the block is resting in the direction opposite to the self-weight. Now, what about the third force? You would have infinite number of possibilities to draw the third force. It could be from right to left, or it could be from left to right, or it could be inclined at a particular angle, or whatever. So you would need more information about the force. I must characterize the force for you in order to make you represent it in a stationary block. Well, how do I characterize a force? For that, I need to define these four parameters for the force: magnitude, direction, line of action, and point of application. Let's look at this example and characterize this force of 1 kilonewton. In this example, we have a cantilever beam. What is a cantilever beam? A beam which is fixed at one end and free at the other. A typical example of a cantilever beam is a balcony in an apartment. So let's go on and find the first parameter, the magnitude. What is the magnitude of the force? Well, magnitude is the amount of the force. In this case, it is 1 kilonewton. So we have the magnitude of force as 1 kilonewton. What is the direction of the force? Well, it is acting downwards, or rather you could say this acts at 90 degree to this axis x. So maybe you can write 90 degrees to x axis. Next we need to define the line of action. Line of action is the line through the point at which the force is applied. So if I draw a line over the point where the force is acting, then this line becomes line of action. So the point where this force is acting is here. So let me draw the line. Let me name it as A dash and A double dash. So this A dash and A double dash becomes the line of action. Alright, now what's the point of application? Well, it's simply the point where the force is acting. In our example, the force is acting at this point. So let's name it as C. And now C becomes a point of application. To locate C, you can measure the length from the fixed point to the point C, so that you can represent this force on the cantilever more precisely. So let's write the point of our application as C, which is, let's say, this length as LC. So the point of application is C at distance LC from A. So that's all about the characterization of force. To characterize a force, you need to define magnitude, direction, line of action, and point of application of the force. Now let's move on to the next section where we will see about the system of forces. Okay, what do we refer to as system of forces? Well, it's simple. When a system has more than one force acting on it, we call it as system of forces. Look at these two examples. In the first one, I have one plane, which is the xz plane. And on this plane, I have some forces acting. Now, look at the second one. I have two planes, the xz plane and yz plane. Now here, I have some forces acting on both these planes. So, here's the trick. Based on the plane in which the forces are acting, you can split the system of forces into two types. The first one, where all the forces acting in a single plane, is called coplanar forces, while the second one, where forces are acting in two different planes, are called as non-coplanar forces. Now, even in the second example, if you consider only one plane, say xz plane, all the forces in the xz plane are coplanar. But on the other hand, when you consider one force from xz plane and one from yz, then these two forces become non-coplanar forces. Alright, now I hope you understand about the coplanar and non-coplanar force system. Another way to distinguish the system of forces is based on the orientation of the force. Look at these five categories. These are the classification of system of forces based on the orientation. Let's look at these one by one with an example. First is the concurrent forces. As you can see, if a system of forces share one single point of application, then they are concurrent to each other. A good example of this would be the tension force acting on the hook of a crane lifting a container. As you can see, the tension forces from the strings T1 and T2 have a single point of application on the hook. So, we can fairly say that these two forces are concurrent forces. Next is the non-concurrent forces. Well, it's obvious from the name itself that if a system of forces are not concurrent to each other, they are non-concurrent forces. Or rather, if the forces do not share same point of application, then they are non-concurrent forces. Look at this example. We have a table, and on the table we have some load. Now, this load will be acting downwards through the legs of the table. Each leg will experience a fraction of the entire load, and each of these load will have their own point of application. In other words, they are non-concurrent. The third category is parallel forces. Here again, as the name suggests, if two forces are parallel to each other, these are parallel forces. A simple example of these kind of forces is a seesaw. Next up is non-parallel forces. These forces are not parallel to each other. Look at this example of a car. Now, a real moving car has a bunch of forces acting on it. But for a simple case, let's just assume that you just have weight of the car acting downwards and the cruising force, or rather the force due to acceleration, acting in the forward direction. Now, these two forces are obviously not parallel to each other, so they come under this category of non-parallel forces. Finally, we have collinear forces. Two forces are collinear if the line of action of both the forces are same. A best example of collinear forces is a rocket flying vertically upwards. Look at this image. The thrust force T is propelling the rocket in the vertical direction, while the self-weight of the rocket and the drag pull were acting vertically downwards. All these three forces share same line of action, so they are categorized as collinear forces. Now we can even combine the coplanar and non-coplanar properties with either of these five category of forces. Here's a nice overview of the system of forces in a nutshell. If two forces which are parallel and find themselves in a single plane, they can be referred as coplanar parallel forces. Similarly, if a bunch of forces which share a common point of application but acting in different plane are referred to as non-coplanar concurrent forces. It is important to notice that there can't be a combination of non-coplanar and collinear forces, because collinear forces by definition must share a common line of action. If two forces are non-coplanar, then they have two different line of action, so this combination is not possible. Good. Now that we learned a bit about characteristics and the system of forces, let's move on and see what is a resultant force. Resultant force is by definition a single equivalent force of the entire system of forces acting on a body. So if you have too many forces acting on a body, and when you can replace all these forces with one single force which can provide same effect on the body as caused by all these many original forces, that single force is what we call as resultant force. Let's look at this example. I have a block and I'm pushing the block to right with force Q, and at the same time I'm pulling this block upwards with force P. Now, instead of applying two forces P and Q, I can simply pull the block diagonally with the force equivalent to the original two forces, which then would look like this. Here, R is the resultant force of the two forces P and Q. Now if you observe closely, you can see that this looks just the opposite of resolving an inclined force into their horizontal and vertical components, right? Well, in this example, it actually is. But for more complex example, it isn't. Anyway, we'll learn about all that things later. Meanwhile, let's look at another example. Here we have a ball falling down. In this case, there will be two forces acting on the ball. One is its self-weight, which will pull the ball downwards to the ground, and other is the air resistance, which will act against the fall. This is another simple case where you can replace these two forces into a single force acting downwards like this. So that's a quick introduction about the resultant forces. In the next video, we will discuss about the methods to calculate the resultant force and look at few more examples. I hope today's lecture was useful. If so, consider giving a thumbs up and subscribe to the channel. I will meet you all again later with another lecture. Bye bye.